This video is on the inverse sine and inverse cosine graph. So if you were absent on Thursday before this unexpected break, please go through this video, or if you were confused at any point during the lesson, this is covering pages 1 and 2 of your 4.7 note. So here I have an example of our sine graph, just our parent function, the sine of x. So by passing the horizontal line test, I would be able to draw a horizontal line anywhere on the graph, and it should only hit it at one point. So you can see this fails the horizontal line test because I could hit the graph at multiple points when I draw a horizontal line. That means its inverse is not a function. However, if we decide to restrict the domain from just negative pi over 2 to pi over 2, we only have this slight curve here. So therefore, by restricting it from negative pi over 2 to pi over 2, it will pass that horizontal line test, which means its inverse will be a function. So what exactly is the inverse sine of x? So it's notated one of two ways. We could say the arc sine of x, or we can have the sine to the negative first of x, except we don't say it as sine to the negative first. We would say that as the inverse sine of x. Just remember when we learned our inverse functions back in chapter 1, it would be f of x and then f inverse of x. So the arc sine of x is the angle whose sine is equal to that x. And we did this a bit in a previous section. You would use the inverse sine when you're solving for an angle measure of a triangle. So because we are restricting the domain of our original function here, we're restricting the domain to negative pi over 2 to pi over 2. Remember, the domain of our original function becomes the range of its inverse. So now we have a range of negative pi over 2 to pi over 2. And looking back at our original function, we have a range of negative 1 to 1. So the range of our original function becomes the domain of our inverse, which is now negative 1 to 1. Now, whenever I have an inverse sine problem, I tend to draw this little semicircle. So because our range is from negative pi over 2 to pi over 2, we're only defined in quadrants 1 and 4. However, make sure that you change these angle measures. We can no longer refer to these as 5 pi over 3, 7 pi over 4, and 11 pi over 6 because they do not fall in our range from negative pi over 2 to pi over 2. So instead, we need to call them again negative pi over 2, negative pi over 3, negative pi over 4, and negative pi over 6. So I want you to pause the video, write down all of these y values, and then use your unit circle if you need to help you evaluate each of those angle measures, the sign for those. Remember, the sign is the y value. So hopefully you took the time to check your work here. Remember, the sign is all of your y values. So look at the graph, make sure that you have this graph correctly. I'm not going to assess you on graphing it, but it's important to see that you're correct in knowing that the domain is negative 1 to 1 and the range is negative pi over 2 to pi over 2. So now we're going to look at evaluating the inverse sine function. So whenever I have these types of problems, I draw my little semicircle here, and this is just a reminder for me to remember that the inverse sine or the arc sine, remember those are interchangeable, is only defined in quadrants 1 and 4, specifically from negative pi over 2 to pi over 2. So when I have the arc sine of negative 1/2, I'm looking for what angle measure has a sine value of negative 1/2. But remember, on that unit circle, that's looking to see when we have a y value of negative 1/2. Now that typically happens down here at 11 pi over 6. But remember, we're only defined from negative pi over 2 to pi over 2. So instead of saying 11 pi over 6, we're referring to that angle as negative pi over 6. So the inverse sine or the arc sine of negative 1/2 is negative pi over 6. Again, try out numbers 2, 3, and 4 on your own when you pause this video, and then you can start it back up again to check your work. You got these answers correct. Number 2 is pi over 3, number 3 is no solution, and number 4 is negative pi over 2. So here's the reason why. Again, so when we're finding the inverse sine of root 3 over 2, we're looking for what angle measures have a y value of root 3 over 2. That is happening up top here at pi over 3. So we do not need to change that angle measure because it's already in quadrant 1. For the inverse sine of 2, we're looking to see what angle measure has a y value of 2. Now that is no solution because there is nowhere on our unit circle that has a y value of 2. Remember, we're only restricted from negative 1 to positive 1. So we cannot take the sign of anything greater than 1 or anything less than negative 1. So here I want to find the arc sine of negative 1. We're looking for what angle measure has a y value of negative 1. and that's down there at that negative pi over 2. So now we're going to repeat this except for the inverse cosine of x. Taking a look at the cosine of x function that I have drawn here, you can see that this also fails the horizontal line test, just like sine of x, and that means its inverse is not a function. Now, if I tried to restrict it from negative pi over 2 to pi over 2, like we did for sine, that little bump still does not pass the horizontal line test. So we have to adjust it. Now we're going to restrict the domain from 0 to pi. So we're looking down from 0 to pi here, and therefore it will pass the horizontal line test, meaning its inverse will be a function. So just like inverse sine, inverse cosine has two different notations, arc cosine or inverse cosine of x. And the arc cosine of x is the angle whose cosine is x. So now we're restricted still from -1 to 1 for our input values, except our range is from 0 to pi. So whenever I have an inverse cosine problem, I tend to draw this little semicircle to help remind me that we're defined in quadrants 1 and 2, specifically from 0 to pi. So we're going to fill in those y values, those angle measures, just like we normally would from 0 to pi. And then I want you to pause this video and evaluate each of those angle measures for their cosines. Remember, the cosine is the x values of these angle measures. Hopefully you've taken a break and evaluated the cosine of these angle measures. Remember, again, it was the x values. And you can see here I graphed it. Again, I will not assess you on the graph of the inverse sine or inverse cosine or inverse tangent graphs, just for you to see that our domain is -1 to 1 and our range here is 0 to pi. Now let's see a problem in which we're evaluating the inverse cosine function. Remember, there's two different notations, arc cosine and inverse cosine. So now we're looking for the arc cosine of 1/2. So again, I tend to draw this semicircle whenever I'm dealing with an inverse cosine problem. So since cosine is our x value on your unit circle, you're looking to see what angle measures have an x value of 1/2 when they fall in quadrants 1 and 2. And that's going to fall right up here at your pi over 3. So go ahead, pause this video again, try out numbers 2, 3, and 4, and then you can start it again to check your work. So hopefully you took some time to answer these three questions. Number 2 is 3 pi over 4, number 3 is 0, and number 4 is none. So here's the reason why. So again, finding what angle measure has an x value or cosine of -√2 over 2. That's going to be happening over here at our 3 pi over 4. For the inverse cosine of 1, we know that the angle measure that has an x value of 1 is happening over to the right there at 0, so 0 is our answer here. Now for the inverse cosine of -3/2, don't think that I forgot that square root there, so don't get that confused with -√3 over 2. We're looking at -3/2. That's about -1.5, and that's the reason we do not have a solution here. Because this is outside of our domain. Remember, cosine, it only goes from -1 to 1. So since -1.5 is less than -1, then inverse cosine is not defined here.